Alright, so we are starting the 7-1 to 7-4 review today. The directions say, write the polynomial in standard form, identify the degree and leading coefficient of the polynomial, then classify the polynomial by the number of terms. This is how it's worded on your take-home quiz, how it's going to be worded on your exam, so make sure that you understand exactly what those instructions mean by the time you take the exam for all of 7-1 to 7-8. You will be tested in the beginning with something like this. It should be easy. So the first one, is that in standard form? Yes, there's only one term. A single term like that is called a monomial. Okay, so it says identify the degree. Well, it's a fourth degree monomial and leading coefficient of the polynomial. What is the leading coefficient? -6. Perfect. Yeah. So on an exam, we just say it's degree 4. Leading coefficient is -6. Classify the polynomial by the number of terms. It is a monomial. And if this were a function like y equals or s equals, then it would be a, let's see, quartic. Okay, 2. How do I get that in standard form? I would put it in that order, yes, unless you write something here to let me know that that is the degree, etc. Okay. So yeah. Because otherwise I will assume that this order is in the order based on the question. Does that make sense? Unless you specify otherwise. Okay, so as you were saying on this one, g squared minus 2g plus 4. Okay, the degree is what? 2. Second degree. It's a quadratic or a function. Not necessarily a function, right? And then the leading coefficient would be 1. 1. Always the first term. And then classified by the number of terms. Trinomial. Yep. I would in your notes write the instructions as well, not just the answers, so that you know exactly what you'll be asked on an exam. Okay, what about number 3? Yeah. -3/8 n to the 5th, perfect, minus 1/4 n cubed. Plus 1/4. You're right. You're right. Okay. Identify the degree. 5. Leading coefficient. -3/8. Classify the polynomial by the number of terms. Binomial. So it'd be a cubic. Okay, last one. What would this be? 2a to the 4th plus 8.1 a cubed minus 1.6 a. Alright. What degree are we missing here? Yeah, a squared. Again, those are important in the future. Alright, so identify the degree. What is the degree? 4. Leading coefficient? Yep. 2. And then classify it. Trinomial. Okay. Do all those instructions make sense? They should. Okay. Let us move on. Here are the answers to the previous question, just in case you weren't able to read everything I wrote down. And here are the next set of questions that involve content in 7.2. Alright, if you're following along, hopefully you took some time to pause the video and try those problems on your own. Here are the answers. Of those, do you need to see any of them? I will work at least one of them. Yes. Which one? Number 8? Okay. I will work on number 8. Alright. Give a little bit of time to write these down if you need to make changes, and then I will work on number 8. Alright. It's just an exercise in combining like terms, so don't overcomplicate it. M squared, M squared. So when I combine those, what do I get? Yeah, a negative M squared. Now, I would follow the order here. So they have M squared, Mn, and then N squared. So here, when I combine this negative 2Mn, this Mn, what do I get? Yeah. And then what do I have last? N squared. Plus N squared. And it does turn out that when you're multiplying binomials, you will have that middle term that has a combination of M and N, and that's why it becomes before just the N squared, if you're wondering. Okay, any other questions on this? Yes.
How do we know when to
Okay, when you FOIL, or just use distributive property, that is when you're multiplying. When you're just combining like terms, that's when you're adding or subtracting. So like here, on number 7, I'm subtracting, so I'm going to put a plus sign, and then a minus, then a plus, then a minus. And then just combine my like terms. So my h squareds, and that of course coming first, followed by my h's, followed by my constant. Yeah, that's a good question. Alright, so we're in our next set of problems. Make sure to pause this, give these a try. These should take you about a minute for each, with the exception of number 11, which you have a binomial and a trinomial. Okay, so I'm going to go over these. Remember, you are just utilizing distributive property. If you have trouble with that, there is an acronym called FOIL that you can use to help you with that. You may have heard of it in biology class, and you can apply the same process here. So, FOIL says to do the first, which we're just distributing, the first term to the x. So x times x is x squared. And then we do our outer. So again, we're just distributing the x to the 4, so that's plus 4x. Then we do our inner, which is 5 and x. So that's just plus 5x. And this should be a plus 4x. And then we do our last, which is 5 and 4, which is 20. We combine our two middle terms. We get x squared plus 9x plus 20. Number 10. Same thing. Distributive property, FOIL, whatever helps you. You can actually turn that into a Punnett square if that helps. So 4 times 3d is 12d. And then you have minus, what's 7 times 4? Maybe 7 times 4? 28. Right? And then your inner terms just minus 6d squared. And then you have plus 14d for the last terms. The order is a little bit strange here, but that's okay. You're still going to combine the terms correctly and then put it in descending order based on the exponents. So we're going to start with what term? Negative 6d squared. That's gone. Remember, I like to cross mine off. You don't have to, but I find that that helps. We have 14d and 12d, which is what? 26D. That's gone, and that's gone, and then we have minus 28. Do you have any questions on that one? Alright, the next one is a binomial and trinomial. This one you can't really quote-unquote FOIL because you have a trinomial, so you have to remember that essentially, again, we're just doing distributive property. So we're going to do that and distribute all of our terms in our binomial to all the terms in the trinomial, combine like terms, and put it in standard form. I'm going to start with my y's. Y times y squared, y times 3y, y times minus 4. That is y cubed plus 3y squared minus 4y. And then I'm just going to move on to the next term in my binomial and distribute that to the terms in my trinomial. So that's plus 6y squared plus 18y minus 24. And then, lastly, I'm going to combine all my like terms, put it in standard form, starting with what? Y cubed. I start with y cubed and cross that off. And then, what two terms will I combine for my second term? 3y and 6y squared, giving me 9y squared. Then, what will I combine? 18 and negative 4y, which gives me 14y, and then minus 24. Is that what you got? Okay, good. You're good with all this so far. You didn't make any mistakes. You're in good shape. I can actually apply a shortcut to number 12. What would that be? What does that look like? Close. That's really close. The other shortcut. This is the one that just becomes a squared minus b squared. What happens to your middle terms? They cancel because I have a plus and I have a minus with the exact same terms. So in other words, a squared minus b squared would be 5z squared minus 3 squared, which is 25z squared minus 9. Now, I talked to one of the upper level math teachers, and they did say that oftentimes when you get to Algebra 2 or to calculus, if you go that far, they will just write this down and they will expect you to know that shortcut. So while you can distribute it, while you can FOIL it to get here, you need to understand pretty quickly or recognize pretty quickly what that shortcut is meaning. Alright. Do you have any questions? I do want to address Zach's point about the other shortcut. Remember, that is when we have a plus b squared. So anything squared, that's when we can say to ourselves, I have a squared plus 2ab plus b squared. So you have two shortcuts. One when you have a plus and a minus in the same term. One when you're taking a binomial square. Trinomial is completely different. Alright. These are the answers for the previous questions. If you have concerns, let me know. Did I forget one on that? Alright, this is the last step before our word problem. Solving the equation. Alright, solve the equation. What are we finding? Do you remember the word? Starts with an R. Good R word, but not the right one. Rhymes with boots. Roots. Yes, roots. What are roots? I mean, other than how new. What are mathematical roots? They're the same as intercepts. They're polynomial function. What are intercepts? Yes, those are where the line crosses the x or y axis. When we're talking about polynomials, and polynomial functions in particular, and we're looking at their graphs, and I say, find the roots of your polynomial function. I want to know where your graph crosses x-axis. So first of all, write a little note to yourself. Roots equals x-intercept. Because I guarantee you will have a problem on your test where you're given a graph. Something like this. And I will say something like y equals 3x squared minus 12x. I will ask you to determine the roots by factoring, or I will ask you to find where the graph crosses the x-axis, something like that. I might not even supply you with what the graph looks like, and I'll tell you, tell me where the graph crosses the x-axis. And you should automatically think, okay, I'm going to have to set that polynomial function equal to 0 if it's not already set equal to 0, which those are, and then I'm going to have to factor. So, for that first one, when I factor, what is the greatest common factor that I pull out from both of those terms? What is that GCF? 3 what? 3x. Remember that what makes factoring different now in Algebra 1 is that we're accounting for the variable as well. So we have a 3 that we can pull out, and also an x. What I ask myself is, what at most can they share in terms of the variable? Well, the first one has an x squared, but the second one just has an x. So at most I can pull out just an x. So take out an x, take out a 3, what am I left with in the parentheses? x minus 4. Remember, it's reverse distribution, or reverse FOILing in this case. And then what do I do with my zero product property? What does that say I can do to solve for those roots? Remember? Make each separate part of that product equal to 0. So 3x is equal to 0, x minus 4 is equal to 0. So x equals 0 and x equals 4. Remember, there is a shortcut. So something like number 15, if you see x minus 4 set equal to 0, you should automatically know that that's just going to be x equals the opposite sign based on the operations. Okay. And oftentimes, remember, we put an or here. X equals 0 or x equals 4. Both of those will give me a product that will yield 0 as my final answer. Okay, 14. What is interesting about 14? I have the same root. I have what's called a double root, right? So in this case, all I have to do is set one of them equal to 0. I'm going to get the same answer. Well, what do I do to solve for y? So I could either subtract that, or subtract 6, or I can add y to both sides, right? Either one. So let's just add y, and add y. And I get 6 equals y, or y equals 6, using my symmetric property. So what's my root? 6. And it happens again. So remember that it bounces there. I won't make you memorize the fact that it bounces there, but that's what happens. Okay, 15 looks difficult, but it's not. What does my zero product property say I have to do in order to solve for all those p-values, all those roots? Yeah, set them all equal to 0. So the first one I set equal to 0, and I solve 4p plus 3, set that equal to 0, subtract 3, subtract 3, I get 4p equals negative 3. So what's my first root? P equals negative 3/4. Perfect. I do the same thing, the other product. 2p minus 5 equals 0. What's my second root? Positive 5 halves? Yeah. What you said? 2p minus 5 equal to 0, and you add 5 to both sides, you get 2p equals 5, and then you divide by 2. So p equals 5 halves. What's my last root? P equals negative 2. Remember, I'm subtracting 2. So I have three distinct roots there, 3 answers. Do you have any questions about 13, 14, or 15 and solving? Yes. That's a great question. It's because, notice, the other ones are already factored out. Yeah, I have the parentheses already. There's nothing I can pull from 4p and 3, nothing I can pull from 2p and 5, nothing I can pull from 2 and 2. Right? If there was a GCS for any of these, then of course I'd pull it. And actually, that reminds me of something I was going to say. Sometimes it happens that you can only pull out a constant, and you end up with, I don't know, 10 times x plus 5 equals 0. Well, in this case, it's not something that's no solution, because of course you can't set 10 equal to 0, right? So you just ignore the constant. But you can set x plus 5 equal to 0, yeah? So if you get to a point where you're factoring something out, and you can only pull out a constant, which does happen, don't let this fool you and think, oh, well, that's no solution because I can't set 10 equal to 0. But that doesn't matter. You can still set the second term equal to 0. You set whatever you can equal to 0. Does that make sense? Okay, cool. All right. Got a lot of writing on the board, so I'm going to erase it. Got any other questions? This is an essential skill, especially when you're trying to find those points that intersect the x-axis. Okay, cool. There we go. Okay, last. So what do I set equal to 0? These are just simple linear equations at this point. What's the first y equal? Yep. What's the second y equal? What's the third y equal? Subtract 2. Negative 2, please. Remember your signs. Okay. Questions? Do you? I fear that you're going to get something like this. And I'm going to ask you what these roots are, and I'm going to give you the polynomial, and I'm going to say, where does this cross the x-axis? And you're going to kind of try and guess. Don't do that. What I'm asking you to do is do exactly what I just did. You understand? Factor it. Use the zero product property to find those roots. Don't just think you can look at it and guess. Because if it was that easy, I wouldn't have you factor it. Right? Okay, cool. Last problem, then we'll be done. For the rest of class. Okay. These are the answers to the previous slide. If you need them, here they are. Last one, word problem. Alright, something like this can look a little confusing visually. First of all, you have to assess what is in the picture. So the 20 inches and the 16 inches, is that including the frame or not? No. It's just including the picture itself. So what this is accounting for is those extra inches the frame is including, right? So that's what we have to factor in when we're finding the perimeter. So what is perimeter? How do I find perimeter? Add all the sides. Well, I can't just simply say 20 plus 20 plus 16 plus 16. So what am I forgetting if I do that? The x's, which take into account the frame, it says including the frames. So if I include the frame, how many x's do I have? I have 8. Here, here, right? Here, here, and then here, 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 here. Yeah? All these corners make those x's. So that's 1, 2, 3, 4, 5, 6, 7, 8. So I have to add 8x. Does that make sense? Yes? No? Okay. Good ACT question, or SAT. I took the ACT in the Midwest, so I think you guys took the SAT more often here. So 8x plus 72 is my polynomial that represents the perimeter. Now it says, write a polynomial that represents the area of the picture, including the frame. So again, I have to think about what this means. How do I find area? I do what? Multiply the sides, right? So if I'm multiplying the sides, what would that look like? Well, let's take into account this one side first. I have an x here and an x here, so how many x's do I have? 2. And then what's the length of the picture from here to here? 16. So that's one side, right? One side is 16 plus 2x. What's the other side? The longer side. 20 plus 2x, right? So I have 16 plus 2x times 20 plus 2x. Does everybody understand where I got that? Yes, I'm including the frame. I have to include the frame for this side, so I have x, frame for this longer side, x, and then 20 and 16. Then, of course, I find the product using my distributive property or FOILing, and you end up with, and I'll just tell you, because we practiced this already, 4x squared plus 72x plus 320. Okay. Now see, I'll just talk you through. First of all, before I move on to see this, everybody clearly understand A and B. Yes.
Which one is A?
A is the pink. 8x plus 72. Do you get that?
Yeah.
And then B is the area, which makes sense. If we're looking at area, we're going to multiply. And so we have to multiply two binomials. That's why we get that polynomial in the end. How would I determine C? Find the perimeter and the area of the picture, including the frame, when the width of the frame is 2 inches. Just plug 2 in. Plug 2 into the pink, and then plug 2 into the blue, and then you get your perimeter and your area. So, in this case, when you plug in to here, you get 88 inches. Remember that you have to include your units. People always forget. I forget sometimes too. You have to remember your units. You are measuring in inches, so in the end you have to have inches. Here for area, what is my unit that we're measuring? Inches, inches squared, inches cubed, inches squared, because I'm multiplying things, right? So in this case, when you plug into here, you have to know your order of operations. Do your exponents first, then do your multiplication, and you get 480. 480 inches squared. Okay. Would that seem something that you could do on a test? Okay, if you are having trouble, again, here's the quiz. I put it as an item in the notebook, but I'm going to take it out. Let me move on to that slide. Okay. So you don't have to have a number 9. I'll add a new number 9 tomorrow. But if you want to do this as an option, just to see how well you do on your own, 7.1 to 7.4, skip number 20, page 384. I will give you the answers tomorrow. So far you should have 8 items on the quiz. Make sure you understand this very, very, very well before we move on to the next half of this chapter.